Snyder here. It is January the 20th, 2013. Okay, so here's I'm going to come straight out and say it right here, okay? Believe what you want, but if you have Google Earth and a big enough screen, and you take the NASA images, the NASA moon images, the lunar images, you want to get big, clear pictures, the biggest, clearest pictures that you can get, the highest detail, okay? Take that picture and flip it over with Microsoft Paint. Flip it horizontally and save it. Okay, and then you have Google Earth on your computer. Hit the overlay button right here and select the picture you flipped over. And then just spend some time. It takes a little bit of time, and you're not going to be able to find things right off the bat probably, but you should be able to find a few things quickly. And make the moon 4 times the size they say, about 3.5 to 4 times the size that they say it is. That's what size you need to do over the Earth, and then just you'll see what you see. Now, if you don't see anything, then I was wrong. But I think if you do that, you'll be in for a big surprise. Okay. Now this is just a bit of weather that I saved a while back. I was going through some of my old overlays up in the list here. It was untitled, and I had forgotten all about it basically. But this is the North Pole right here, okay, Greenland, and I have it saved and overlaid in the Pacific. Well, what I was looking at the time, I suppose, I mean, a reverse moon image brought me to this location. I didn't just search around and wonder where to put it. I brought it to this location to put it with basically the Hawaiian island chain. That angle, you see the angle? Okay, that's what I was working with. I guess I was working on something in this area. I don't remember what it was, but anyways, I looked at it today, and this is see this curve that comes up like this. Okay, this is the weather that day when I saved it. Okay, the weather shows everything. So this, you see the curve right, this little curl right here. See that? That's the. See how it follows that curve? This one right here. Here, in case you got a small screen. Okay, you see that curl? Okay, right there. Okay, and then you just follow this down, and plus you got the angle there. It's following that angle of the Hawaiian island chain at the same time. Look at Japan. This is ancient weather, ancient Japanese weather right here. Look at that. Look how it just hugs that line right there. I don't even remember any of this, lining any of this up. I was probably working on more like lining it up with this center and these lines here, but I didn't even see any of this last time. Or I would have remembered it. I would have saved it. That's really nice how that goes. Look at this part right here too. Right here. How the weather comes in that. Look at that. It's right here and right here. It fits in there perfect. Comes back here and then goes down. Comes like this and down, just like it does in the land there. Look at Japan, it fits there really good. That is perfect. Japan is perfect right there. And then you come over here, and you got Greenland. Oh, let me just mention, Iceland just happens to fall where Hawaii is. It just happens to fall right there. Look at that. Isn't that something? Thought people might find that interesting. Starting to see something else I recognize right here too. See that pattern right there? You see that pattern? Okay, and look at this pattern right here. You see that pattern right there? This weather pattern is showing us what this used to look like on the Earth. That's showing us what that used to look like right there at the North Pole on the Earth. The weather pattern is absolutely showing us that. Because what this weather pattern all the weather patterns on the Earth, what they show us, what they follow are prints that are not necessarily left by the moon. Yeah, I guess they're left. Well, I don't know. You can take your pick which shapes what. I mean, which the Earth shapes the moon or the moon shapes the Earth. I guess they shape each other, right? If they hit each other, it's kind of complicated. But that's what that looked like for a long time on the Earth. I bet you that's exactly what this part of the North Pole looked like, and I bet you that's what this looked like too in the Pacific right there. Hawaii and Iceland in the same place, and then look at Greenland. Look at the shape of Greenland, and then look at the ocean floor right here. Right there. Okay, and there's Iceland again. And then you can just start putting impacts up here. I haven't done that. I mean, I have probably some that go in this area. But that is a beautiful. Actually, I did try to put the South Pole there earlier because the South Pole has the same pattern. So do the Himalayas. This is the same pattern as you see in Asia. Right here, China. This is the Himalayas, I do believe. This is the plateau. Right here. Yeah, I could take that right over to, or I could bring Asia right over here. Watch, it'll fit right there. I think I already have Asia. One Asia over here somewhere, but it's over this way a little bit. But that puts like Siberia over Japan, or right in the same area where Japan is, and it fits there pretty good, I think. Gets complicated. It does really get confusing. I mean, but this has to be ancient weather from. I mean, this weather had to be. Japan had to be at the pole at one time. I would say. All this stuff used to be at the pole that's behind this picture. This stuff used to be up there where this used to be, or where this is right now. Used to be, Japan used to be in that same place. I bet you. Right, Japan used to be up here, right here. Hold on. Okay, I'm back. I forgot where I left off. But anyways, yeah, Japan. I think it was Japan. I was saying. Since this weather this weather right here was up here when I saved the picture, I'd say that would be where Japan was at one time, because the weather stays the same even though the land moves away. That's what I've noticed, that even though the land moves away, the weather remains the same on the Earth. It leaves it's some kind of magnetic pattern or something over the ocean. The patterns stay the same. They come back and they hold to the pattern of the moon. Wherever the moon hit, whether the land's moved away or not. Like I pointed out before, the ancient weather down here that's, for the, it fits in Africa. And where is it? There it is. When I always say, go over here and you can just bring, here's the Sahara and everything right here. This is Africa, ancient weather, where Africa used to be here at one time. Because you can see that Africa was shaped by this weather right here. A lot of this weather. So that's what I'm saying. This weather, that just kind of shows. Let me see what the weather is here right now that matches this weather at all. Not really. I see some similarities, but not enough. But anyways, pretty interesting how Hawaii. That's a tough one to figure out, kind of. I think. That's an interesting weather pattern right there by Iceland. But that's just that big old crater, I think, that big giant Schrodinger crater right here, with Iceland hitting right in the center, and now apparently Hawaii too. I would say. It looks like I don't know. That's what is so damn confusing is you see like the print from Greenland in the ocean right there. And you see that V, but that V is not only there on the Earth; it's other places. It's on the land too. I should find out where that is, because this is pretty interesting. This big hole, that clearly shows the big giant volcano left over after the impact. Right there, that's the huge volcano right there. That big shape right there is the center of the impact. I could put the South Pole over that right now. I might as well just do it. Since I said I could do it, I'll just do it. I can find it. Should be the last one I just did. Not that one though. I'll go. I don't want to move it. Yeah, I can move that one. Alright. Here we go. Oh man, it's getting close to the pole up here. It's going to get kind of weird. Okay, here we go. Really close already. I'm pretty close already. Look at that. I think I'm almost there. Let's see. I want the Schrodinger crater. Where is it? There it is. I need to crop this picture seriously. It's got way too much stuff on the side there. Alright, I think it looked better at the beginning. Like something like that. I think that's it. Hide that center pretty good right there. Here, I'm going to get a different picture. Get a different one. Okay. Okay, so here we go. This should be real simple. So just get the size right. Just get the size right. And this isn't the whole moon. This is just the South Pole. So this is in a circle shape, but it's not the whole moon. I mean, it's just I just say the South Pole of the moon. So okay, so it looks like it goes. See, and the weather might be curving that bottom a little bit too. Sometimes that happens. I can get it right though. I know I can't get here. Oh yeah, I'm starting to see this right here. This crater in the weather. Something right there in that weather. Right. I pushed the Schrodinger right there. Okay, hold on. Almost got it. That's right. I see the craters now. I'm starting to see the craters in the. Okay, it's going to turn. Yep, I almost got it right here. Real close. You can see this. You can start to see this line that comes out the side. See, this is a Google moon image, and it's really a shitty image. I mean, you can't really get much detail from this moon image, but I can see this line start to come out the side right there. I think it goes. It's pretty close right there because I can also see like this point right there in the clouds. See how this shape is right here, and how it comes down like this. That is there. That is absolutely there. Yeah, you can see the tip of that right there in the clouds right there. See that? Yeah, I think that's there. I'm pretty sure. And I can see this line right here come across. Yep, I see that too. In that crater's right here. I got it just a little bit off, but close enough. I can see that crater right there. Look at this one right here. In the weather. Right there, sure enough. And then this one is that one in the weather. In the weather, you can see this one right here is how it's kind of got the rough these funny edges. Look at the edges right there, and then look at the crater. Okay, that goes right there. And you can come down here and see these two right here. See how I can see the whole thing. Just this whole crater right here is right there in the clouds. Look. See that big round shape right there? That's that crater. I'm telling you. That's pretty good right there. I mean, they don't give you the outside. They don't give you the edges. They won't give you the edge. They won't give you the outline of the crater. Not on Google Moon. Hell no, they won't. But I guarantee that goes right there. That South Pole of the moon on the North Pole let's just check it over. Take away the that other picture. See how it goes right here in the middle of the Pacific. And you can see when you do that, I can see the V right there. Watch, look at that. And you can see like this right here with this. I mean, they don't give you shit for detail in these images from Google Moon. I'm telling you, but you look at that. I can see the V. This goes here. I mean, it doesn't necessarily go here. I mean, but yep, it shapes. I'm telling you, it hits the same spot on the Earth every time, or almost every time. But it pushes it aside or something. I haven't figured that out yet, but it hits the poles every time. And Japan, like I said, Japan had to be right here at the pole at one time. That weather shows it. Absolutely shows it. Absolutely does. That weather absolutely shows it. Now I'm going to try and bring up something else. Let's see, Tycho in the Hawaiian Island chain. And you can see like the outline of that big circle right there. See that right there? Watch. You can see that it shares a similar pattern, and this is Tycho hitting the same spot. Okay. And this is a terrible picture of not Tycho, but the other one. This is from that LRO. It's rectified Tycho, but it goes right. This is an application placement. I can see the big circle right there for that Schrodinger, and you can see how it centers right out. See how it's centered right perfectly. How it's centered perfectly, and you can see the angle going off this way, and you can see the angle going off this way. And we're doing this together. I have never done this right here before. What I'm doing, but I can see that it's all coming together, because it always does that. It always comes together. Look at the big circle right there. That's that big crater, because it hits the same place. They hit the same places. So the prints all over the moon share similar patterns. I just did one earlier. These ones earlier that I lined these two craters that are right next to each other. I think they're yeah, I'll show them to you right now. These two right here. These are you can see these two craters in exactly like this on this over here on the moon in this area over here on the back side of the moon. Okay, these two craters don't just whatever hits the moon right here hits other spots on the moon and creates the same exact pattern right here. Same thing. That's what I'm trying to say. It hits the same place on Earth, and you can see I didn't try to line that up with this Tycho crater, but it just lined itself up. It lined itself up, and it takes practice to look at the details, but you can absolutely if you have a big enough screen, you can sit back from your monitor a little bit, and you'll get the hang of it, and you'll see things like, see this big circle right here? It looks like you don't notice it till you put the crater right behind it, and you go, whoa, that falls into place kind of. And you just work with those little things, and you'll get it. You'll get the lines figured out, all of it. I mean, that just fell right into place. And look at those angles. Look at this right here. I mean, it fell right in the dead center of that. Look at that. You definitely see that circle right there. And I can do that with I can bring up Mare Orientale and put it right here too, and it'll fit right here too. It'll fit with that same picture, because they all hit the same place on the Earth. Or it used to anyway. It used to hit the same place on the Earth. I mean, I'm showing you all these different sides of the moon that just line up. I got so much. There's so much more I could show you. I just can't hardly remember half of it because there's so much. So much. And then you got your live weather. You can turn on your live weather and check it out with all these ones that you do and confirm. Some weather is better. Some days are better than others, and some seasons are better than others. You gotta wait for the season sometimes for certain patterns to fit really good. This fits in here. It's just hard to see this one today. Okay, what else I got to put right there? I'm just going to put that weather pattern back over there so you can get a good view of that. That weather pattern is important. Absolutely important. And I don't know if I mentioned it in this video, but this is the Himalayas right here, and this is the Hurricane Sandy. This shape is all over the place. This shape is right here, right there. See that? Right there. And if I was on my other hard drive, I would show you what I'll make another video about it. I made one earlier. I think I might have deleted it. But that is what the patterns in the weather show what basically used to be there. I mean, whatever land was right here at this time, this is what it looked like. Right here. Oh, I gotta. You know what? I'm gonna find out what it is too. I'm gonna find. Oh yeah, that's gonna be good. Now all I gotta do is I could put this right here there. That's probably it right there. That's that's the land that was there at the time when the moon hit right there. Yep, right at the North Pole. Like I said, the weather doesn't move. The weather moves, but I mean it stays the same in the place where it was hit. I mean it basically stays the same pattern over the ocean, as like I said before. It stays the same. It doesn't change. Like there's ancient weather all over. I can show you it all day. I mean, look at that pattern though. You can see that fits there. I'm not saying it's perfect yet, but it's pretty good. And that's because the only reason why it don't fit perfect is they don't give me all the details in that Google Moon image. That's what sucks about Google Moon, is just kind of confirms some things. Some areas you can't get a good picture of. You know, they just don't give them to you because they're too obvious. I've found that out too. When you go to get one that's just going to blow it all up, you know, you just can't find one that's good enough for that crater to to prove it. So it's just got to keep working at it. So there you go. Too much time on that one. So, but that's pretty important, I think. Again, I mean it had to happen here at one time. This had to be at the pole, right there. That had to be at the pole, this whole area. And I've heard it before. Documentaries that the North Pole used to be in the middle of the Pacific, they say, and I don't doubt that one bit. I'd say the Pacific used to be at the North Pole. It's more like, that's probably what I would say. Say it like that. Not the North Pole used to be at the Pacific. I'd say the Pacific used to be at the North Pole. I think the poles stay in the same place. I think the land moves away or something. Hard to figure it out. Anyways, let's see what weather we got around. The weather's really crappy lately. Plus, they're still hiding this strip for the 4th day in a row now. Four days in a row. No weather here for 4 days. Must be a hell of a pattern behind there or something. And then we got this right here, this big curve. And I marked this right here because it's like the center of the other day it was like the center of the curve, and it's right in the center of the Mid-Atlantic Ridge. And I took my the roller and I went across around the world, basically to where it flipped, and that ended up being right here in this spot here, which is really close to where the impact would be that I just showed you. Let me see. Let me get the back up here again. See, there's the center of where I say the impact happened, right there where that weather. Here, turn this live weather off, damn it. That'd be the center, and that'd be the opposite of the Mid-Atlantic Ridge right here. So it's really close. I mean, if I was to go from here, let's see what happens if I go from here. And who says everything? It was directly here. The weather could be off a bit. I'm not even really for sure, not right on. Uh-oh. Showing it right there. I would say that had something to do with breaking up of Africa, and well, I don't know. It's hard to figure that out too. It's really complicated. But there you go, right on the ridge, right on the Mid-Atlantic Ridge. I think almost all this ridge is from the moon impacting the other side, leaving this weather pattern like this right here. It curves like this. It just basically centers. Where was it centered? Right here somewhere. Yeah, it's centered right here somewhere along the ridge. Pretty interesting though to try to figure it out. I mean, there's so much more to this. So much more. That's a cool weather pattern right there. I got one that'll fit that one. I know I do. Watch this. Okay. That one's not doing. Yeah, it's doing okay today. Nothing special. Kind of see that right there. This is hard weather to get to fit sometimes when it falls right when it's all softened like this and there's no really good storms going on, and it's kind of hard to line stuff up like that sometimes. The weather doesn't really fit because it's so kind of soft around the edges. That's kind of strange. What I want to show is the weather pattern that I found last night. I don't know if is it here? Oh, it is here. Okay, here's the North Pole last night. See, this is last night's weather at the North Pole. See that? There's Greenland right here. This is Greenland. And there's Iceland right there. See that? There's Greenland, Iceland, and just look at the weather last night, and then look at tonight. I mean, right here. Look at tonight. Just totally different weather. But look at this pattern anyway. This pattern is pretty incredible. And I have it really big right now. I have it set big so you can see it easier, I guess, because I have to do it in the Pacific. I can't do it at the pole. You cannot overlay a picture at the poles where the moon hits. Where the moon hits, you cannot put a picture of the moon here. It will not let you. Not on the South Pole either. Okay, you have to put, if you're going to do work on the South or North Pole, you have to save a picture of it and put it in the Pacific Ocean or somewhere on the equator where the picture does not get messed up. Okay, anyways, this pattern, again, this is another pattern that's pretty incredible. And I lined up the South Pole on that one, and the South Pole is going to be big too on this one. But the pattern matches very well with this crater. Actually, this crater right here is shown to hit Iceland. I don't know. I might have it off still. I got to check it. But it looks like the same shape around the outside. I'm still working on that one, but I do think it goes here. That pattern. All right, I just got a text. Got to check my phone. All right, have a good day. Check it out. If you watch my other videos, you'll probably get more of an idea of what I'm trying to show here. All right, have a good day.